Welcome back to the fourth session of pshcrometry. In this session, we will discuss an important problem related to pshcrometry, the most important repeated problem. So, I'll write out the problem. An air conditioning system is designed under the following condition: outdoor condition 30 degrees Celsius diabulb temperature and 75% RH. Required indoor condition 22 degrees Celsius diabulb temperature and 70% RH. The amount of free air circulated is 200 meter cube per minute. This is the source we can take it for finding mass flow rate. So 200 meter cube per minute is used to find m value. So note it out. Coil dew point temperature is 14 degrees Celsius. This is the maximum surface temperature of the coil. Surface temperature of the coil, that is dBTS, that was already mentioned in bypass factors. That is the temperature. The required condition is first achieved by cooling and humidification and then by heating. So there are two set of process: cooling and dehumidification, one set, another by heating. Heating here is sensible heating. So estimate the capacity of cooling coil in ton, capacity of heating coil in kilowatt, amount of water removed in kilogram per second, surface temperature of heating coil if bypass factor is 0.3. So we'll start solving the problem. Given 30 outdoor condition dBT 5, that is RH value 75%, indoor condition dBT 2 22 degree 5 to 70%, amount of free air circulated is V1 dot, that is equal to 200 meter cube per minute, converted to meter cube per second, it is 3.33. So 1 minute 60 seconds was made and divided, so it becomes 3.33 meter per second. The coil dew point temperature dPT is equal to 14 degrees Celsius. The psychometric processes are cooling and dehumidification. First one, heating. Next one, to find QHC, capacity of heating coil, then QCC, capacity of cooling coil, M V dot, mass of water vapor removed, dBTS. So that is final one. So dBTS is the surface temperature of heating coil. So we can see step 1, plot the outdoor condition of air, that is 30 degree and 75% in psychometric chart, and as well as plot the indoor condition 22 degree and 70%. That was also shown with this model psychrometric chart diagram. So first one 30 degree and 75 percentage, it is point number 1. So this is RH curve, this is 30. So from here we are going to intersect and make it as 1. Similarly 70 RH curve, and from here 22 degree put a vertical line and meet the intersection of 70 RH curve and 22 degree dBT, vertical line becomes point number 2. The process is actually from 1 to 2, but how it happens? It is happening in two part. So step 2, plot the coil dew point temperature 14 degree as point number 4 on saturation curve of psychrometric chart. So dPT, that is dew point temperature, is the temperature at the end, that is RH 100% line. The last curve is RH 100% line. There we have to plot dPT, that is dew point temperature. This is not a drivable temperature, it is different, 14 degree. So it was plotted like that. See the plotted point. So connect that plotted point with 1. So this is 4, actually 14 degrees Celsius is available here, somewhere here. If you want doubt, you can go to this psychrometric chart. See, this is, I'm marking out 5 10, sorry, minus 5 0 5 10 15. No, this is actually the temperature, dew point temperature value. So here the 14 somewhere lies between 5 and 10. So this is the line. So here it was plotted. So you can see again in the model diagram. So you have to connect that 1 to 4 with a line, straight line, so that may be an inclined line. So again draw a horizontal line from 2 to intersect this 1 4 line, make it as 3. Now you achieve the real process. 1 2 3 and 3 2 2. 1 2 3 is sensible cooling and dehumidification, 3 2 2 is sensible heating. So again 1 outdoor condition, 2 indoor condition, 3 outlet of C plus DHF or inlet of heating coil, 4 coil dew point temperature, and then So 1 2 3 it is sensible cooling and dehumidification. 3 to 2 it is sensible heating. So again I am repeating this process. So to achieve from 1 to 2 we are having two part. One is sensible cooling and dehumidification. Another process is sensible sensible cooling and dehumidification and heating. These are the two processes. These two processes are identified with help of this coil dew point temperature. How? So plot 14 degrees Celsius in this curve as 4. Connect 1 and 4 like this straight line. So it will be an inclined line naturally. So this inclined line you can connect this inclined line from to a horizontal line. So there is an intersection of this horizontal line and inclined line, mark it as 3. So 1 2 3 is one part and 3 to 2 is another part to achieve the condition from 1 to 2. So 1 2 3 accounts for sensible cooling and dehumidification. 3 to 2 means for sensible heating. So by this identification of point we can directly take all the values from psychrometry chart. So what we are doing this, so we'll go back again to solving the problem. So take HWV at point 132 from psychrometry chart. So outdoor condition dBT 30, 5 175, point number 1, H value is 82. How? So we need to go to this chart actually. So if you go to this chart, if you park a point 1, you can go to this line to get enthalpy, the last line. On the same manner, whatever thing that we need, W value and V value, everything can be obtained by this psychrometry chart. So W value, if this is the point, go to this right extreme line, then you can get W value, and then this vertical slant lines, if you identify, you can get that small v value. So from that point it is H1 is 82 kilogram per kg, W1 is 0.02 kilogram by kilogram of dry air, V1 is 0.88 meter cube per kg. The same manner, point number 3 we get H3 W3 dV3. Then point number 2 we are getting H2. As W3 equal to W2, don't need for finding W2 here. Step 4, capacity of cooling coil, formula Q123 is MA into H1 minus H3. H1 is found from the psychrometry chart 82, H3 is 48, MA you can get it from V dot by small v. V dot already you know 3.33, small v is the value here, V1 value 0.88. So divide 3.33 by 0.88, we are getting 3.78 kilogram per second. Substitute here, get the value of Q dot, that is 36.72 tons. So you have the relationship. So 1 kilowatt can be taken, and if you want to convert 1 ton is equal to 3.5 kilowatt. So this conversion 36.72 tons. The same manner, capacity of cooling coil MA into H2 minus H3. So apply, get the value in tons as for 5.4 tons. Then mass of water vapor removed, or capacity of dehumidifier MA dot into W1 minus W3. So every value is available, substitute, so you can get 0.032. Then heating coil surface temperature, so using the bypass factor formula, as bypass factors available, dBTS minus dBT2 by dBTS minus dBT3 equal to 0.3. Substitute dBT2 and dBT3 that is given, then dBTS can be found as 24.35 degrees Celsius. So this is about the important problem. Any doubt you can ask me at any time. Thank you.